There are 2 trillion galaxies in the universe, and we will never reach 99.99% of them, ever. Not because we don't have the technology, but because they're literally running away from us faster than light itself. Space exploration always feels like it's heading toward something bigger, right? We went to the moon. We're planning missions to Mars. We're talking about colonies on Jupiter's moons. And eventually, maybe we leave the solar system. Then we explore the Milky Way. And after that, other galaxies. That's the vision. That's what science fiction has been telling us for decades. We just keep expanding outward, further and further, until we've explored the whole universe. But here's the thing nobody talks about. That's never going to happen. Not in a million years, not in a billion years, not ever. Because the universe itself is working against us. And the problem isn't technology or fuel or distance. The problem is that almost every galaxy in the universe is already unreachable. They're moving away from us so fast that even if we could travel at the speed of light, which we can't, we'd never catch up. Today, we're going to talk about why humanity is stuck, permanently stuck. Not just in our solar system or even our galaxy, but in a tiny bubble of space that includes only a handful of galaxies. Everything else? Gone. Forever. Here's the core problem, and it's going to sound insane at first. The universe is expanding. That's not new information. Scientists have known that since the 1920s. But the expansion isn't slowing down, it's speeding up. And because of that acceleration, distant galaxies are moving away from us faster than the speed of light. Now, I know what you're thinking. Wait, nothing can go faster than light. Einstein said so. And you're right, nothing can move through space faster than light. But space itself? Space can expand as fast as it wants. There's no speed limit on the fabric of space-time stretching. So what's happening is this. Galaxies aren't flying away from us through space. Space itself is growing between us and them. And the farther away a galaxy is, the faster the space between us is expanding. At a certain distance, that expansion becomes faster than light, which means that even if you could instantly accelerate to the speed of light and point yourself directly at one of those distant galaxies, you would never get closer to it. You'd be running on a treadmill that's moving faster than you can run. That distance, the point where expansion overtakes the speed of light, is called the cosmic horizon, and anything beyond that horizon is unreachable. Not difficult to reach, not maybe someday with better technology, physically, fundamentally, permanently unreachable. The challenge isn't building a better spaceship. The challenge is that the universe has a built-in barrier that we can never cross. Let's rewind for a second and talk about how we even know this is happening. In 1929, an astronomer named Edwin Hubble, yeah, the guy the telescope is named after, discovered something weird. He was looking at distant galaxies and measuring how fast they were moving, and he found that the farther away a galaxy was, the faster it was moving away from Earth. This wasn't because Earth is special or because we're at the center of anything. It's because space itself is expanding in all directions. Every point in space is moving away from every other point. If you were standing on a planet in a galaxy billions of light years away, you'd see the exact same thing. Everything moving away from you. Hubble's discovery was huge. It meant the universe had a beginning. It was smaller in the past. It's getting bigger right now, and that expansion is happening everywhere, all the time. But for a long time, scientists assumed the expansion was slowing down. It made sense, right? Gravity pulls things together. So even though the universe was expanding, gravity should be pulling back, slowing it down over time, maybe eventually stopping it altogether. Then in 1998, 2 teams of scientists made a discovery that won them the Nobel Prize and completely changed how we understand the universe. They found that the expansion isn't slowing down, it's speeding up. Something is pushing the universe apart. We call it dark energy, but honestly, we have no idea what it is. We just know it's there because we can see its effects, and it's winning. It's overpowering gravity. It's making the universe expand faster and faster. And that acceleration changes everything. Okay, so if the universe is expanding and most galaxies are unreachable, what's left? What can we actually get to? The answer is the local group. The local group is the name for our little cluster of galaxies. It includes the Milky Way, Andromeda, and about 50 smaller galaxies. Most of them are dwarf galaxies, tiny things with only a few billion stars, but Andromeda is massive, even bigger than the Milky Way. These galaxies are close enough to us that gravity is still holding them together. The expansion of space is happening, but on this scale, it's weak enough that gravity wins. So the galaxies in the local group aren't flying apart, they're actually moving toward each other in some cases. Andromeda, for example, is heading straight toward us. In about 4 billion years, the Milky Way and Andromeda are going to collide. Not crash like two cars. Galaxies are mostly empty space, so the stars will just pass by each other. But the two galaxies will merge into one giant galaxy. Scientists have even given it a name already, Milkomeda, or sometimes Milkdromeda. Yeah, it sounds silly. But here's the point. The local group is it. That's our entire accessible universe. Everything outside the local group, every other galaxy cluster, every supercluster, the entire rest of the observable universe is moving away from us faster than we could ever travel. There are about 2 trillion galaxies in the observable universe. The local group contains about 50. Do the math. We're stuck with 0.0000025% of the universe. Let's talk about the cosmic horizon in more detail, because this is where it gets really strange. The observable universe, the part we can see, has a radius of about 46 billion light years. That's how far light has traveled since the Big Bang, accounting for the expansion of space. But the cosmic horizon is closer, much closer. It's about 16 billion light years away. That's the cutoff. Anything farther than that is moving away from us faster than light. And here's the weird part. We can still see those galaxies because the light they emitted billions of years ago, back when they were closer to us, is still reaching us now. But if you tried to send a signal to one of those galaxies today, it would never arrive. You could aim the most powerful laser in the universe directly at them, and that beam of light would travel forever and never reach them, because they're moving away faster than the light is traveling toward them. It's like trying to swim upstream in a river that's flowing faster than you can swim. You're moving forward, but you're being pushed backward even faster. And here's the really messed up part. That horizon is shrinking. Every second, galaxies that were barely reachable are slipping over the edge. They cross the cosmic horizon and become unreachable forever. And once they cross it, there's no coming back. Imagine watching a ship sail toward the edge of the world and then just disappear. Except in this case, the edge is real and it's getting closer. Now let's talk about what this means for the future. Not human-scale future, cosmic-scale future, billions of years from now. Right now, when you look up at the night sky, you can see thousands of stars with your naked eye. With a telescope, you can see billions. You can see distant galaxies, nebulae, star clusters. The universe feels full. But that's not going to last. As the universe continues to expand, galaxies outside the local group will move farther and farther away. Their light will get redshifted, stretched out into longer wavelengths until it fades into the infrared and then disappears completely. One by one, galaxies will vanish from the sky. In 1 trillion years, yeah, 1 trillion with a T, The only galaxies visible from Earth will be the ones in the local group, and by that point, the local group will have merged into a single giant galaxy. So if you looked up at the night sky from a planet in that future galaxy, you'd see stars, lots of stars, but no other galaxies, just darkness, empty expanding space in every direction. Astronomers living in that distant future wouldn't even know there was a Big Bang. They wouldn't have evidence of cosmic expansion because everything outside their galaxy would be gone. They'd look out at the universe and think they were alone, that their galaxy was the entire universe. And they'd be right, because for them, it would be. That's what we're headed toward. A lonely, dark, silent universe with just one island of light surrounded by infinite nothing. Okay, let's bring this back to the original question. Why can't we leave our galaxy? The short answer is, we can. We can leave the Milky Way. We could, in theory, travel to Andromeda or one of the dwarf galaxies in the local group. It would take millions of years, even at relativistic speeds, but it's not impossible. But we can't leave the local group, because everything else is already too far away, and it's getting farther every second. Let's do some rough math. The nearest galaxy cluster outside the local group is the Virgo cluster. It's about 65 million light-years away, and it's moving away from us at about 1,000 kilometers per second because of the expansion of space. That doesn't sound too bad, right? 1,000 kilometers per second? Fast, but not faster than light. But here's the problem. The farther you go, the faster the expansion gets. By the time you reach the edge of the local group and start heading toward Virgo, the expansion rate increases, and the farther you travel, the worse it gets. Even if you were traveling at 99.9% the speed of light, which is way, way beyond anything we can do, you'd still be fighting against the expansion of space. And because that expansion is accelerating, there's a point where it overtakes you. You'd never arrive. You'd just keep traveling forever, getting farther from home, but never getting closer to your destination. It's not a problem we can engineer our way out of. It's not a matter of better engines or more fuel. It's the fundamental structure of space-time working against us. Here's one of the strangest things about all of this. Right now, we can see galaxies that we will never be able to reach. Their light is arriving at Earth. We can study them with telescopes. We can measure their distance, their composition, their age. We can see stars being born inside them. But we will never go there, and we will never communicate with anyone who might live there. If there's an alien civilization in one of those distant galaxies, and they're looking back at us right now, they're seeing the Milky Way as it was billions of years ago, back when the solar system didn't even exist yet. And if they tried to send us a message, that message would never reach us. It would be chasing us forever through expanding space, never closing the distance. We are cosmically isolated, not just from other galaxies, but from entire sections of the universe that we can see but will never touch. It's like being in a prison where the walls are invisible and infinitely far away, but absolutely real. So is there any way around this? Any loophole? Any future technology that could break through the cosmic horizon? The short answer is no. Not with anything that follows the known laws of physics. You'd need to travel faster than light. And not just a little bit faster, you'd need to go significantly faster than light to outrun the expansion. But faster than light travel breaks causality. It leads to paradoxes. It's not just hard, it's impossible according to everything we know about how the universe works. Some people talk about wormholes, shortcuts through space-time. And sure, if wormholes exist, and if we could create them, and if we could stabilize them, and if we could aim them at distant galaxies, then maybe. But that's a lot of ifs, and we have zero evidence that any of that is possible. The universe has rules, and one of those rules is that we don't get to explore all of it. We get a tiny corner, a handful of galaxies, and that's it. The rest is just something we can look at, study from a distance, wonder about, but never visit. Here's the moment that really hits me. Imagine you're an astronomer 1 trillion years from now. You've dedicated your life to studying the universe. You've built the most powerful telescopes your civilization has ever made, and you point them out into space. You see your own galaxy, billions of stars, planets, nebulae. It's beautiful, it's vast. But beyond that, nothing, just darkness, empty space stretching on forever. You'd have no idea that there were ever other galaxies, no idea that the universe used to be full of light, no idea that there was a time when the sky was crowded with billions of galaxies in every direction, because all the evidence is gone, redshifted into invisibility, pushed beyond the cosmic horizon by the relentless expansion of space. You'd think you were alone, and you'd be wrong, but you'd have no way to know it. That's where we're headed. A universe where the past is erased, where the evidence of the Big Bang is gone, where entire sections of reality become unreachable, and then invisible, and then forgotten. We're living in a special time. Right now, we can still see the full universe. We can still see galaxies that are billions of light years away. We can still see the afterglow of the Big Bang in the cosmic microwave background. But that window is closing, and it will never open again. We're not just stuck in the local group, we're stuck in a moment in cosmic history where we're lucky enough to see what we can never reach. Let's bring it all together. The universe is expanding, and that expansion is accelerating because of something we call dark energy. The farther away a galaxy is, the faster it's moving away from us because the space between us is growing. At a certain distance, the cosmic horizon, about 16 billion light years away, galaxies are moving away from us faster than the speed of light, and because of that, we can never reach them. Not with any technology that obeys the laws of physics. The only galaxies we'll ever be able to visit are the ones in the local group, about 50 galaxies, including the Milky Way and Andromeda. Everything else is already too far, and it's getting farther every second. In the distant future, all the galaxies outside the local group will disappear from view. The sky will go dark, and civilizations living in that era won't even know there was ever anything else out there. We're stuck, not because we lack the technology, not because we're not trying hard enough, but because the universe itself has a built-in limit that we can never cross. There are 2 trillion galaxies in the universe, and humanity will only ever have access to a few dozen of them. The rest are gone forever.